So it's this. Should be a relatively short lesson. These slides are pretty short. Does he use the same slides I'm using by chance? Yeah. Okay, so you've already seen all the material, so we can go through really quickly. Any questions, let me know. So I realized using slideshow mode means the recording is all black. So I'm keeping it like this for now. The fundamental counting principle is what we're going over today. This is the objective. Use the fundamental counting principle to determine the number of possible outcomes in a given situation. That's the objective. If you want to take a picture or not, whatever you want to do. We're good here? All right. Definition: if you can choose one item from a group of m items and a second item from a group of n items, then the total number of two item choices is m times n. So you have a tree diagram to look at if you want to. That's pretty much what it is. Applying the counting principle, the Greasy Spoon restaurant offers 6 appetizers and 14 main courses. How many ways can a person order a 2-course meal? Well, just do 6 times 14. That's all the different combinations of appetizers and main courses that you can do. Are we good here? Any questions about anything? So, the counting principle with more than 2 groups of items. Definition is the number of ways in which a series of successive things can occur is found by multiplying the number of ways in which each thing can occur. So number of possible outfits from 2 pairs of jeans, 3 t-shirts, and 2 pairs of sneakers. It's the same thing as 2 items, just multiply everything together. Well, the number of things in each group, multiply them all together. That's how you do it. So, this is a big example, but essentially all it's saying is that you have 3 different courses to pick from, 8 different math courses, 5 different English courses, and 4 different humanities courses. How many different ways can you make your schedule? Will be 8 times 5 times 4, which is 160. Multiply it all together, you're going to get your number of course schedules you can make. Everyone with me, guys? Any questions? No? So a multiple choice test. So if you have 10 questions, each one has 4 choices. You have 4 to the 10th way of answering the question, or of having different answers. So that is 1,048,576. Right, that's essentially what the question's asking. If you have a 10 question test with 4 choices each, how many different ways can you answer? 4 to the 10th, because it's 4 times 4 times 4, 10 times, which is 1,048,576. We're good? Any questions about anything? All right, telephone numbers. It's gonna be the same. What's it called? The same logic. So 7 digits. Area codes and local telephone numbers cannot begin with a 0 or 1. How many different telephone numbers are there? Well, your area code, because you cannot begin with a 0 or a 1, you only have 8 choices. 2, 3, 4, 5, 6, 7, 8, and 9. Then you have 10 and 10, or 10 different choices from 0 through 9. Multiply it all together. You get, what's that, 1, 2, 100,000 million, 6.4 billion. That's it for 11.1. Are we good here, guys? I'm going through it kind of fast. If you have any questions, stop me. We can go over it. Are we fine here? All right. 11.2. Permutations. These are the objectives. You can write them down or take a picture, whatever you want. So we use the fundamental counting principle to count permutations, evaluate factorial expressions, use the permutation formula, find the number of permutations of duplicate items. All right, we good here? So permutations is an ordered arrangement of items that occur when no item is used more than once. The order of arrangements makes a difference. And you understand what this means, right? When we say that no item is used more than once and the order of arrangement makes a difference. Does that make sense what I'm saying or not really? Yes, not really. So essentially, what it's saying is that if you have, let's say I come up to you with like two boxes of like red balls and blue balls, right? Let's say there's 10 balls each. We'll make it simple, right? And I tell you, well, you can take one from the red ball, and then you can take one from the blue box, right? Well, in that case, order matters. I'm asking, well, how many different combinations can you do? Actually, maybe a better example is you have two boxes of balls. One is numbered 1 through 10. The other one's 11 through 20. Right? Kind of make it that way. So I say, well, you take one ball from the 1 through 10 box and then one from the 1 through 20 box, right? So say, well, how many different combinations of balls can you make? Well, that is where nothing gets used once. Because when you take a ball out, you can't put it back in. And then the order arrangement makes a difference because it'll be different if you grab a 1 then a 12 compared to a 7 and a 13, right? And so in that case, order matters because it depends on how many combinations can you make, right? Does that kind of answer your question a little bit? Okay. Counting permutations, you need to arrange 7 of your favorite books along a small shelf. How many different ways can you arrange the books, assuming that the order of the books makes a difference to you? So I guess that's a lot better example than I was saying. But you have 7 books, you're going to put them on a shelf, and the order matters. So you can put it 5,040 different ways because the what it is 7 times 6 times 5 times 4 times 3 times 2 times 1. Because what it's saying is that, well, the first slot in your bookshelf, you have 7 choices to pick, right? You have 7 books. Well, the second slot, you only have 6 choices now because you put one of those books in there. The third slot only has 5 choices now because you already put 2 of the books on the bookshelf, and that's why it keeps decreasing by 1. Because each subsequent choice has one less book to pick from because you put that book on the bookshelf already. Make sense what I'm saying, guys? And that's what it means when you say, well, order matters and you don't replace it. And it essentially is still the counting formula we did in the last one, 11.1, is that the numbers will decrease because you have one less choice to pick. So that product is called 7 factorial. It's 7 with an exclamation point. It just means multiply 7 and go down one number each. So 7 times 6 times 5 times 4 times 3 times 2 times 1. That's what a factorial is. 0 factorial in this class by definition is 1. So 0 factorial is just going to be 1. Are we good here, guys? Any questions? So using factorial notation. So evaluate without using your calculator. So if you have 8 factorial over 5 factorial, what you'll see, I don't think it's very clear what it's saying here, but essentially the top, you have 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Let me just write it. So the top is essentially 8 times 7 times 6 times 5, 4, 3, 2, 1. And the bottom is essentially 5 times 4 times 3 times 2 times 1. Like that's what's happening here. And that's why when you multiply it, well, all of these are canceling out. You're just left with 8 times 7 times 6, or 336. That's what's happening. Are we fine with that? Any questions there? All right, 26 factorial over 21 factorial. It's the same logic. Essentially, just the 21 factorials cancel out because that's all that's left. You're just left with every number bigger than 21 up to that 26. So 26, 25, 24, 23, 22 is all that's left over. And that gives you 7,893,600. Are you fine with that?
So it has the same number.
Yeah, because 21 factorial is, well, 26 factorial is 26 times 25 times 24 all the way down to 1, right? And 21 factorial is 21 times 20 times 19 all the way to 1 as well, right? So that's why when you have 26 factorial over 21 factorial, it's just going to be all the numbers from 21, not including it, up to 26. Because they cancel out, right? 26, 25, 24, 23, 22. 8 factorial over 5 factorial is every number after 5 up to 8, so 6, 7, 8. Because everything below is just going to, from 5 down is going to cancel each other out. Kind of make sense? Yeah. Everyone else, are we okay? So here's a formula for permutations. You have n permutation r. It's n permutation over n minus r permutation. Or not permutation, sorry, factorial. N factorial over n minus r factorial. Make sense? Ready to keep going? So, you and 19 of your friends have decided to form an internet marketing consulting firm. The group needs to choose 3 officers, a CEO, an operating manager, and a treasurer. And how many ways can you choose these offices to be filled? So you have 20 people to choose from, and you need to choose 3 people. Its credentials don't matter. All that matters is you're picking randomly. So you have 20 people. That's the 20 in the beginning. Permutations with 3 people. So you want to see, well, how many groups of 3 can you make? It's 20 factorial over 20 minus 3 factorial, or just 17 factorial. So it comes 20 times 19 times 18, or 6,840. Make sense what I'm saying, guys? What's wrong? So because it's 20 permutation 3, so what the permutation formula is saying is, well, if you have 20, in this case, you have 20 items, and you want to see how many groups of 3 can you make. It's 20 permutation 3, so that's why it's 20 minus 3 in the bottom. Because the formula is this right here, n factorial over n minus r factorial. So it's n is how many items total you have, r is how many groups you're making. So you have 20 items, and you're making groups of 3, in this case right here. So it's 20 factorial over 20 minus 3 factorial, which is 17 factorial. Make sense? Everyone else, are you okay? All right, the formula for permutations of duplicate items. So the number of permutation of n items where p items are identical, q items are identical, and r items are identical, and so on is given by this. So how many identical items you have, it's just that factorial on the bottom. So you can write this down if you want. If you already have it written down from the other class, we can just keep going. Are y'all ready? Sure, go for it. I am going a little quick because y'all said you've seen this stuff. So if I'm going too fast, let me know. We ready? All right. So as an example, in how many distinct ways can the letter of the word Mississippi be arranged? So there is 11 letters. So you have 11 letters to choose from. But the problem is you have 4 I's, 4 S's, and 2 P's. So you have some duplicate items in there, which is just the same letters. So that's why the permutation is now 11 factorial over 4 factorial times 4 factorial times 2 factorial. The reason why is because it doesn't really make a difference if you pick the first I compared to the last I, right? An I is an I. It doesn't matter which one you picked. That's why you have to break up the bottom factorial to 4 factorial, 4 factorial, 2 factorial. Because there are some duplicate items where you can't really do much with it, right? An I is an I. It doesn't matter which one you picked. It's all the same thing. Does that make sense, guys? Any questions about that? No? All right, I think that's it. Yeah. That's all I have. So, rest of the class, do what you want. Y'all kept your test, right? From last class?